everyone. I can see from the list there's a few names I know, but I'll just quickly go over myself. So I'm Jared Asquith. I'm one of the senior engineers here for Nexus. Mostly work around the custom robotics scopes and a few of the advanced NDT stuff that we do. My main focus is in like technology trials and sort of developing or integrating technologies for site purposes. Sort of the InService diesel tank's quite a good example of what we do. So I'll just quickly, like most presentations, I'll skim through the About Us page. So for those who don't know, we're Nexus. We started in 2014. We're started off as like a rental company that mainly focused on like RVI and DT techniques. We really found sort of during the process of dealing with industry and dealing with clients that there was a sort of a gap in the market with the robotics, and that's where sort of people like myself came into Nexus, and we started working on the inspection robotics side of it, just in the rental space, so taking off the shelf products and helping support them through rental opportunities and sort of complex scopes. And then it's developed from there into more of a consulting, custom solutions, and this is where we found that the off-the-shelf stuff just kind of didn't tick every box all the time, and we've started to focus on that. So through that, Nexus is, like when I started, I was employee number 8, I think, and now we're up to, it's 40 plus there. I think actually globally we're about 50 people now. We've got a team in Houston, about 5 guys over there, a couple of guys in Singapore, and then a reasonably big head office here in Perth now. We have 2 premises in Perth, and then Houston and Singapore, obviously. Part of our sort of growth and development through our rentals and dealing with sort of custom scopes, we started to notice a few gaps, I guess, is how you'd say it in the process. So to support that, we've actually started a few different value streams for Nexus. The first one is 6D, and so 6D is our machine shop. We have like a full 400 square meter CNC mills, EDM machines, wire cutters, stuff like that. Like we have a full machine shop which is supported by our engineering team, and a lot of that came around is especially in oil and gas and the water and mining, a lot of projects had really short time. So we'd get a phone call and then a month later we wanted to be on site doing a trial. And we found that bringing machining in-house was key to being able to sort of deliver that rapid prototyping and custom solutions quickly. Nexus, the main sort of revenue stream, that's the core of our business. So that's where we still do the renting and leasing. It's where most of our engineering team sits in a sort of consulting capacity or design capacity, and a lot of where our solutions are driven. And then lastly, this is a new sort of comer to our business, and that's Lab 61. So we realised through sort of sale, rental, trials, everything, that there was a lack of sort of understanding in robotics and industry, and you get some person, and not putting anyone down or anything, but you get some person who's been on site for 10 years, put boroscopes or an eddy current technician or something, and one day someone will just decide that they're going to drive a robot in a vessel and do an inspection, and they've had no formal training, no understanding of how like a robotic platform works and what the recovery mechanisms are, what the planning is required just to put a crawler in the vessel, what the scan plans, those sort of things. So we created Lab 61, and Lab 61 was really about the training from like end to end. So we weren't just familiarizing someone, we're not just familiarizing someone with the product. We're sort of teaching them the holistic view of how to deploy robotics in industrial situations, and be that subsea, in a vessel, pipeline. Like we're sort of training workshop has all those scenarios, and that's how we test our robots. That's how we train people. So we're working to set this up as a RTO, so it'd be like a registered course that people could do. I might. So almost done with the sort of introductory slides. So for our sort of business to function, we have like those sort of 3 value streams that support sort of our core. And the main thing is like we want to come across as a solutions company, not a rental or a quick fix. Like we want to be the company that people approach to support on sort of long-term complex problems. And we do that through, I guess, our engineering design, our sort of consulting team, I guess you call it, the rapid prototyping, the custom robotics, and we're building quite sort of robust workflows around these processes. So here's one of them, and we call it the end-to-end solution process, and we use this a lot for like vessel inspections. And the idea is a client comes to us, they have a problem, we take that problem, we ask the questions, with the checklist, we build a sort of an understanding of the situation. From there, we will simulate. So we've created our own like sort of CAD, and we're moving it into like a ROS platform simulation software where we can put a camera in the vessel digitally and see how that will perform and see what the camera should see and provide sort of feedback to the client before we even get to site. We'll go on the vessel saying that we can cover 80% of the vessel with this equipment, we can cover 100% with this, and so that's kind of sitting, I'm not sure if you guys can see my mouse, but in this area. And then we sort of bring that out. We don't do services ourselves, we'll do trials, but we'll work with the service company, and we'll bring that out to like a PDF of the simulation, or we can have a 3D model on site, and it just gives the idea for the guys doing the scope, like where do they insert a camera, where do they insert a crawler, where do they drive, what do they see, those sort of things. And then part of the sort of robustness of what we're trying to do is we want a lot of feedback. We know we're not always going to get it right the first time. We know that every vessel's slightly different, so we're quite engaged in the end of the process as well on learning and then building up our knowledge base for the next vessel, the next inspection, the next scope. So we're constantly sort of growing our understanding. I'll just pause there for a minute before we actually start the diesel tank if anyone's got any questions.
Jared, it's Rick. Can see your mouse, mate. Quick question from one of the attendees. You mentioned the American office. Just where is it, and I guess what capabilities are there? Just a summary of a pretty good question.
Yeah, that's a good question. So it's based in Houston. It's been operational for I think about 6-8 months now. It's heavily focused around the robotics. We've got the rental, a couple guys who focus on sort of renting our core fleet there. Then we've got some guys who have come over from NDT backgrounds who can support the advanced NDT stuff. And then we've got a couple guys who liaison with like Rick and myself, like they're part of the engineering team on the more complex scopes. So we're pretty well covered over there for capabilities. Before the COVID situation, there was a lot of us sort of toing and throwing from Houston to support the office as well. If I can share the contact if anyone's after it for the Houston manager, and we can push it from there.
I've got the attendee's name as well, Jared, so we can just sort that out afterwards. It's easy.
Cool. No worries. No more questions. We'll move on.
Perfect.
Cool. So what we're talking about today is in-service diesel tank inspection, where we created a sort of custom solution. We we did it here in Australia. It was for an energy operator. Just to kind of set the scenario, it was about 6-8 weeks out from a major shutdown they had. They had a lot of works on site for this shutdown, a lot of welding, and part of the scope of the shutdown was to do the first 10-year inspection on this tank. The client came to us with the service provider in hand, so it was kind of a perfect scenario for us. And they were asking for a solution where they could inspect this particular tank without emptying it. So this is an ignition diesel tank, so reasonably clean diesel, 10 years old, and it never, as far as we understood, had never been emptied and inspected. One of the main drivers for the client not wanting to empty this during the shutdown was they didn't want to bring in auxiliary or spare tanks. This was their only diesel tank on site, and they didn't have too much options apart from temporary storage, and didn't want to go down that route because it's costly and risky. And then the second was that there was a lot of works happening during this shutdown, and emptying a diesel tank and having a crew doing reasonably risky confined space entry during a shutdown just adds some complications. And then I guess for all sort of inspections, I know a few people on here on this list, and I know that you're all pretty seriously involved in inspections. The outcomes are the real driver. So we set a goal that we don't want to sort of 100% tick this tank off. We just want to get it extended for 4 years, because that coincided with their next shutdown where they had a lot less works planned. So it kind of worked out well there. So part of the Nexus process, we covered it before, the client and the service company approached us. We sort of started with the questions and evaluating the situation. Obviously, inspecting an online diesel tank is reasonably complex and comes with a bunch of sort of questions. So what we looked at, and the first thing we always look at is what is the requirements? Like, what do we have to do to get this signed off? What's the coverage that we need to do? What are the requirements for the inspector to say, yeah, this tank's fine? So a lot of that was the UT coverage. We had to do UT, we couldn't just do visual. And then providing adequate visual imagery to back up the UT so we could look at the condition. And then the last was like the locating. So we had to know where we were and be able to locate in the tank so we could say that, yeah, this area looks great, this area doesn't look so good. And then I guess finally, one of the other big areas that we focused on was the angulus plate for the client and for the inspector. The angulus plate around the tanks, obviously the higher risk area than the sort of center plates. So with that in mind, we knew UT was an option. UT was the option we had to go with. We knew we had to provide some sort of good quality camera. We didn't know from experience, we didn't know what the rough conditions were inside. Like, we didn't know if there has been like scaling coming off from the roof and settling on the tank. We didn't know how bad like the sludge that you get, the organic growth you get in diesel was. We don't know what the conditions of the tank were. So the first step we took was actually putting a SP120. So we had a stainless steel high definition camera, depth rated to 300 meters. And we just got that put in the vessel first. And the idea was that just to have a look around and sort of understand the situation before we went too far down any path. So first off, just a quick visual inspection. Next challenge we found, so with the visual, we've noticed a lot of sludge, and you'll see it, I think, in the next slide, on the tank. So we had to test how UT would perform in diesel, let alone sludge. So obviously, different fluids have different viscosities and change how UT works, changes the speed of the sound. So there was a fair bit of in-house testing on just how UT is going to perform, and are we going to be able to actually do that through diesel, through sludge, and through a mixture of both. The next was how would diesel affect our systems. So our systems, I've got one behind me, but this is not the one we use, but systems are track-based crawlers, which use rubber belts, a lot of O-rings. So we had to check what O-rings would be affected by diesel. Would the rubber be sustained in diesel for long periods of time or not? Are we going to have any leakage? Are we going to cause damage to the equipment? That sort of thing. So we did a few, this is all before we came up with a design. We started testing our tracks in diesel, checking the O-rings, making sure stuff wouldn't leak. And we got positive outcome from that. So I guess the sort of pieces of the puzzle come together. We know UT works, we know the tracks and the crawler works. We had to do a little bit of surface preparation, and we didn't have a tool that would clean. So that was the next step, was just creating basically a wire brush just to prep the surface. And I guess for those who know UT, know that you need a reasonably clean surface, even if you've got a lot of fluid or product, just to get an accurate reading. So that the surface preparation was, you'll see in the next slide, a big part of what we did. And then lastly was the scan plan, and the scan plan came into locating, being able to provide like an accurate representation of the data. There wasn't too much we could do in terms of, it was just upfront planning, so we knew how we would deploy, which ways we would drive in the tank, how we'd track that, but there wasn't too much we could do in the way of testing for that. So that was really the, sorry, I'll just go back.
Just a couple of questions when you're ready, Jared.
Yeah, I was just stopping for questions and then lost control of the slide.
You mentioned the scan plans. There's one question on scan plans and then another one on the size of the asset. Maybe let's start with the size of the asset.
Yeah,
do you remember approximate height, approximate diameter?
Yeah, so approximately, I think that was 12 meters high, and I think it was 8 meters diameter, so reasonably big. Off the top of my head, it was about 150,000 litres cubed, I think, meters cubed. I do say it somewhere. So a reasonably big tank. At the time of inspection, so when we went in with the camera, it had about 8 meters of head on it. So I guess it was about 10 meters high from memory. And then when we actually did the inspection, they lowered it right down just because they were coming to pre-shutdown. So it had about 3 meters of diesel in it, of air pressure at the time.
You touched on the scan plan. It was only the floor of the tank. It wasn't the shell.
Yeah, so the shell, they were happy, because it was so low, they were happy to have a camera and do visual, which we supplied a camera for, but we didn't have to do UT. So the main focus was on the floor of the tank, really focusing on the angulus plates. However, the solution that we have was magnetic, and if we needed to, we could have put it on the walls. Just the deployment would have been a bit trickier, and we would have had to probably create some solution around that. But yeah, sorry, I didn't hammer that. So the focus was on the tank floor. One of the interesting features on the tank floor, and most tanks have them, was an anchor level. So you basically had a anchor point on the bottom of the tank with a wire going straight up to the top, which is obviously when you're driving around with a tether, it's dark, it's hard to see. Was a really, one of the high risk flags that we had out was getting wrapped around that anchor point. And then one of the others was there was a sump where it dropped about, from memory, about 30 centimeters, 300 mils at the bottom. And we talked to the client and service company, and that wasn't a requirement to check the sump. I think this was a good tank because it had pretty clean diesel and it was reasonably new.
I think you've touched on this one a few times now, Jared, but with the scan plan, if you maybe just explain, okay, you focus on the annulus, but what else did you focus on internally?
Yeah. So the Angular, how we did it was we deployed, I think, a manway here, and then we traveled around the Angulus. When we got full circle, we actually came back and then set ourselves 100 mils off and then drove again, taking UT readings. I think it was every 10 mils, 100 mils at the time, around there. Once we'd done the Angulus, and you could quite clearly see by the UT data that we're off the Angulus plates, because there's quite a big shift between, I think the Angulus plates were something like 15 mils, where the floor plates were 9 mils. So with that and the distance, we knew we were off the Angulus. So we covered the Angulus quite heavily. And then for the center plates, we basically, from the manway, from where we deployed, we drove in a sort of, hopefully not upsetting anyone, but like a Star of David sort of pattern, like we were coming across and then across again on another angle. And that was talked up front with the client, and that gave us enough coverage of the floor, and gave us a good pattern where we could say we're sort of covering, I guess, the floor. We're probably only talking coverage about 40%, but it was good coverage. Saying that, there's no reason you couldn't do 100%. It would just take a lot longer, and we only really wanted to spend two days on site. So I hope that covers the sort of scan plan and what we actually did on site.
Thanks for the questions as well. For those who came in a little bit later, there is a couple of buttons down the bottom. So there's a Q&A button, there's a chat button, but also there's a low and raise your hand if you actually want to verbally ask a couple of questions. But yeah, appreciate those questions. Let me know if I didn't answer it, and we'll jump into it a little bit further. Just one more, Jared, just while I get my head around it.
Yep.
So how close did you get to the floor shell weld internally doing the scanning? So I guess how close did that UT get to the floor and shell section, but internally?
What you can see here from the crawler, and that will give you an idea. So we were driving, and again, hopefully you can see my mouse. We didn't have all three cleaning heads on. We only actually had the one head. So the edge of the crawler was basically this orange line here. So as we're driving around, we had that set pretty close to the shell wall, and we're driving around, but you're still probably talking 150 mils offset. I'd have to look at the data. There were a few times where we drove straight in, but the issue was the camera is poking out and the UT's behind it. So we might have got about 100 mils with that, but that was more, we're doing it out of interest rather than part of the planned inspection. So I'd have to go back and look over the data, but I'd say it was about 100, 150 mils we were offset from the shell.
I don't know if you want to take one step back, Jared, and maybe just, because that wasn't really part of the scope, is to try and get as close as we needed to be. Maybe just explain the capabilities of 6D, and maybe if we do have a chat earlier about how this could have been done a lot closer, if it was part of the scope. Yeah,
like again, the UT part or the NDT part's actually probably the easiest part of this. I was kind of going to explain the crawler first, but actually I might do that. I'll explain the crawler first because that will give you guys an idea. So this is basically the solution that we came up with. That big silver knob at the top's a pan tilt camera. We used a standard F1 in this just because we were close enough to what we were expecting. We didn't need to use a high definition camera, and a high definition had some complexities that weren't really necessary. I said before we only kept one out of the three of the cleaning brushes on. It just wasn't necessary to have that much cleaning because it was driving flat. It was a pretty clean situation already. It was just more if we actually struggled to get a reading, we wanted to fire up the cleaning. In here is where the UT probe sit. So it kind of sat in the center front of the crawler, I guess. And that's great for when you're driving up a shell wall or a flue or something like that. You can just take a nice reading. Not so great if you want to get close to the shell of a tank like we're talking. But in saying that, like the UT side of it's pretty easy, like even putting a phased array probe, or we've done some eddy current stuff with these as well. You can basically put them anywhere we wanted on the crawler. You just got to know where you are, and it's all scope dependent. And this is kind of what Rick was touching on. This is where we use our machine shop and capabilities there a lot. We can easily 3D print a mount for different UT probes, or we can easily machine something up and quite happily move it to any location on the crawler to cover different aspects of an inspection. So going back, so the solution we ended up using was encoded B-scan. For those who don't know, B-scan is basically you have a wheel as you're driving along, it triggers the UT. So from memory, I think it was about every 100 mils, it might have been 10. We take a reading, and that's great because it just gives you that nice, even location data. Like, you know, you're driving along, and every 10 mils, 100 mils, you're taking a reading. You get this nice little A scan that shows it. So B scan and having that encoded trigger was key in this. PT's a camera we kind of covered. One of the biggest things with this solution was actually nothing to do with the robotics. It was more the educating both the service company and the operator about putting crawlers in diesel, putting anything in diesel. There's a lot of people out there who had some misconceptions, I guess, around diesel being flammable, not combustible, and we had to do, and it's the right thing to do. We had to do a lot of testing and proof of concept around like our fail safes. So we knew the RCDs in the system would trip after 16 milliseconds, which is well within the dive safe standards. We had pressure switches on it, so the system wouldn't fire up till it's completely submerged, and that's because more so for gasolines and stuff, but we didn't want any potential point of it arcing in the vaporous area. So little pressure switch on it, lowered it into water, lowered it into diesel, and then the system came online. So we made some mitigations, but the biggest challenge really, and that was educating people around what's safe, what's not. We get this all the time. Was it EX rated or ATEX certified? And the system wasn't. We didn't have anything on there that was, and it wasn't actually a requirement. It wasn't, again, a flammable environment. It was something that's combustible, and diesel's got quite a high ignition point. All the electronics on board were subsea rated. So like there's that sort of inherent safety there as well. So that's really, again, the sort of solution we proposed and ended up designing and building and doing the job with. I'll just pause there if there's any questions.
Just a broad one, Jared. I might make it just the brushes in the front. Someone was asking, what are they for? I guess maybe if you just explain that we developed it and some of the future uses we're using it now, I guess.
Yeah, cool. So for UT, if you have any build up on the surface, so like certain paints and stuff are fine, but if you get a little bit of rust, bubbles, that sort of build up, even like sludge when it settles, it's really hard to get an accurate UT data through. So these are just like a wire brush. I wish I had one here to show you guys, but just the same as a wire brush like you'd use to sort of scratch off paint or clean your barbecue almost. It was a motorized version of those which just span and just clean the surface. We developed these as a sort of more precautionary for this scope. the client didn't want to spend all this money, all this time getting into the asset and then realizing that we couldn't get UT because it wasn't clean. So we put them on. I think we fired them up a couple of times just to see how it goes, but we used quite a soft bristle wireless brush on them, and worked perfectly, but not really required. But since this scope, we've used them for some dry inspections where we're going vertically up on like cooling towers and stuff, and using it to do a bit of surface prep before we take the UT. And it also helps with the tracks driving and like maintaining cohesion. So I hope that covers like what the brushes were for.
Does, Jared? There's one more question. Do you mind going back to the previous page? It shows paint surface. I think there's some questions. Okay, I can see the question. So there was a question around the image on the right, mainly asking if the UT can go through the broken down coating.
Yes and no. I'm to be honest, Rick's probably more the UT specialist than me. In a tank, it's a reasonably good situation because you've got a lot of bonding. So the problem with this is it's dry, and you'll get air between the paint coating and the surface. So you'll have a lot of attenuation on your signal. To the point of it might completely degrade it. In the tank that we did, I might just skip to that slide. You can
so just
see
with
here,
that one, I guess, Jared, that actual concept drawing was made before we really knew what was going on inside the tank. It was really just a concept for a client to show, this is what we're proposing. Are they comfortable with the idea before the investment happens? Get some stakeholder engagement. So this drawing, this sort of CAD model was really done as an early engagement item to get some buy-in from a client. But Jared's spot on though. So the UT, if there's an air gap, the UT won't travel through it. So if the coating's bonded, or if it's an epoxy and it's bonded and there's no inclusions and no air gaps, and it's not fibrous like a fiberglass, then the UT would travel through fine. It's just selecting the correct probes, but then using those brushes that Jared has in that photo as well, you can clean up the surface. But I guess just to put that photo or that picture in I guess perspective, that was done before we really knew what the inside of the asset looks like. But there's some options to do UT through coatings as well.
Yeah. Thanks, Eric. Just kind of jump to the end. So this is the photo of the crawler. So this is using that silver camera at the front, looking down. You can see there, like the sludge build-up, pretty minimal. Diesel, reasonably clear conditions, but probably the key feature here is like the surface coating on the tank floor is in great nick. So there was no issue of the paint peeling back and us having to go through tricky situations. And I guess we had the wire brushes on there to help with it if we needed to, but it wasn't really required. And I guess just to conclude, the job was successful. We got the tank extended out for 4 years, which was our target goal. Some of the sort of key things we achieved was eliminated a confined space entry requirement, which was a big win for this operator. Reduced the scope of work during the shutdown. So we actually did this about 6-8 weeks prior to the shutdown, and the reason we did it then was because if we couldn't get it signed off, they still had contingency to bring a tank in and inspect it during the shutdown. But it was at the right time period where they could quite easily not mob that if they didn't have to. Cost saving was around about 500,000, and like that's not a figure coming from me. That was a figure coming directly from the client, and I guess, like if you look at the cost of bringing a tank in, bringing some confined space entry, some ropies, that's probably about right. And then we've put off the clients having to inspect that tank for another 4 years, which is really what we were set out to achieve in the scope. So that's really it for the diesel tank presentation. If there's any questions, I'm happy to hang around and answer.
A couple coming through, Jared.
Yep.
It might be worth explaining, I guess there's a two-part question. So how did you negotiate any obstructions internally? So was there obstructions, pop supports internally? And then maybe just explain a little bit on the simulation software that we use for these sorts of things as well.
Yeah, cool, perfect. So first, there were a few obstructions. There was even a piece of like PVC, like 2-inch PVC pipe just floating around on the bottom, I guess from construction or something. There was a few outlet pipes. So I guess for those who are familiar with tanks, they don't normally just weld it straight onto the shell. They actually come in a little bit. So again, a lot of this was captured up front in the scan plan. So we weren't just driving around the outside of the shell in a perfect circle. We were driving up to these features. Most of them sat off the ground, so we weren't too worried about the tether going under them. But we'd just go around and then continue on and have them as like a blank spot of where we couldn't inspect. I touched on it before. They use the old wire level gauge, so anchored wire, and it's just a steel wire going to the top with a float on it. That was identified as the single riskiest part in the tank, and we basically left quite a clear area around that where we weren't happy to travel, and it was just too risky. Like if for some reason you got lost and turned right, you would tie up the tether. So it was just easy to identify it and treat it as a no-go zone. And that's also why we went in the same direction, like around once, and then came back in that direction and then back again. So the tether was always managed in a single path, not potentially tying up around things like the anchor points. The sump was there as well. That was a feature we recognised that we talked about. We talked about potentially going into it, but decided it was not worth it. Like the benefits from inspecting the sump to not were minimal. So again, we left that out. Like we really just focused on the 80%, the stuff we could easily achieve with this inspection. The simulation software, we've actually got a webinar coming up for it. But really what it is we started it in CAD, and it was clients would come with a vessel. For this, it was like we had a GA of the drawing and we drew it up in CAD. And we weren't too advanced when we did this scope, but we basically just moved a box around and sort of with a tether attached and saw how it all performed. The simulation software really comes into its own when we start looking at pressure vessels, things with like baffles or demisters, those sort of things. And what we've done is we've got probably one of the biggest inspection robotics fleets in the world, plus cameras, boroscopes, all those things. And we've had a team, a lot of our grads came in and they set some measuring criteria. So we set up a container, we set up some charts where they could set up a camera and basically work out like where's that camera's optimal focus point, how would that perform when it's really close, when it's really far away, what's the light output, and capture all this information and put it into a big sort of selection matrix. And we did the same with our sort of off-the-shelf crawlers as well. So we created like kinematic models basically of how they perform. So like how much magnetic force, how much tether pull until it fails, what can you see from where, those sort of things. And we've built this sort of selection matrix. And then we use that with the simulation software. So for us, like a pressure vessel, we'll build it. We'll drop a mag HD or a crawler in that through the manway, and we'll see what that crawler should see from that inspection, provided that the GEA or what we've built is correct. And that gives us a really good idea for, like someone goes, we want to cover 80% of this vessel, but we only want to go through this inspection port. We can say, well, through that inspection port using this tool, you can get 60%. But you need to open up this one and go in that way, and then you'll get 100. Or it just gives a bit more sort of credibility to approaching scopes and what equipment you recommend. So that's really the simulation tool. So I think Nick, one of our main engineers who drives the robotic simulation stuff, is going to do a webinar in the next few weeks on how that really works, and have a few sort of examples of that. Cool. Any more questions, Eric? Or?
A couple more coming through. I hope you're ready for this one. It's good. I guess the relationship between client, Nexus, and service provider, I guess how it worked for this project. There's a couple other things here as well, but maybe just how it worked for this project and how we want to do that in the future.
Yeah, that's a good question. It's one we get a lot. This was a good scope. We had a good relationship with the operator. We'd been involved in a lot of technology trials already with them. We also had a really good relationship with the service company, and done a lot of stuff with them in the past. We did have a lot of issue between service company being a service company. They've invested in equipment and they wanted to empty the tank and sort of do it the way they've always done it, and that's just how it works. And it makes sense. It's the right approach for them. Us being the sort of technology company and the operator pushing for a sort of niche solution, we had to help a lot with kind of getting the service company 100% on board. But when they did, they were very supportive, very good. And it was actually good having that sort of challenge point for them, because the operator was so go, they wanted the solution. It was good having the service company going, well, hang on, how are you actually going to meet this criteria and deliver an outcome which will satisfy us to be able to pick off the tank. It was just a good situation where we had a good relationship with both service company and operator. But we see that a lot through other scenarios as well. We tend to maintain a good relationship both with service company and operator, and we don't want to be on site doing inspections, doing jobs. We really want to prove a technology, develop a technology, and then train a service company to deliver that. And that to us, and hopefully to operator and service company, is the best outcome. So cool. Hopefully I got that one.
It's a good one. It comes up.
Yeah.
Give it a couple more minutes, Jared. Maybe if you want to close off with some of the extra webinars coming up. Just there's one more coming through. I can just see someone typing. But if yeah, maybe you can finish off just with the webinars coming up.
Yeah. So obviously due to the sort of current situation, and it might be getting better soon, but we've pushed through a few of our technology webinars and just talking about some of the things we've designed, created, scopes similar to the diesel tank, and then even some of our more complex technologies that we're working on. So LiDAR location, that really ties in with the simulation stuff. So we're working closely with CSIRO on developing a tool that you can put into a vessel, and it will build a 3D world of that vessel. And then the robotic or the camera is positioned in that world. So when you take a photo or capture an image, you can say that image was captured at exactly this location. which is great if we find a pit or a crack or something. We can say, well, that's exactly there, and so the ropey or the person who ends up going in to check it knows exactly where they had to. So that's the LiDAR location. Lab 61 I touched on that, so that's just talking about our capabilities as a training, like what we're doing, where we're going with that, the sort of training facility we're setting up. 60, so that's just again talking about some of the sort of prototypes, some of the, like we're doing some pipe clamps, just cool stuff we're doing there. I think that would be quite an interesting one to go to. Remote NDT on robotics, so that's similar to this where we've done like UT. It's talking about some of the like eddy current stuff we've done. So we put pulse eddy current on the crawlers before, along those lines. The custom solution, the weight heat recovery, that's actually sitting behind me. So that's sort of, it's a crawler on a crawler. So I'm not sure if you can see that we've got 2 crawlers on here. That's designed to drive down a bigger pipe work and deliver the smaller crawler onto some offshoot pipes. So that's, I think Rick will probably be talking on that one. Magneto, which is that picture there on the right, that's another project we're doing with Cyro. So this is a kind of electromagnetic walking platform. The idea of this is like wheel and track-based systems aren't great in complex geometries. So we've sort of teed up with Cyro to bring a kind of new edge to this. It's about a year away, but we're at the point of sort of field trials now with it. So it's just really sort of showing where we're at, what we're doing, what sort of tooling we can chuck on it, how it works, those sort of things. And then the last one is Elios 2, which will be one of the guys called Cooper, who's a trainer. He spends a lot of time doing trials on site and talking about Elios and proving it as a sort of worthy inspection or screening tool, especially for vessels and tank inspection stuff. So yeah, so that's what we've got upcoming. I think a lot of them would be similar to this, posted on LinkedIn. You might get an email and you can register. So yeah.
One more question, Jared.
Cool.
This one's based around, and I might actually elaborate on this one a little bit, but it's based on timing, how long things took. So maybe take it from the beginning. How long did it take a client from the initial discussion, I guess, to get us to site? How long was that initial discussion?
Yeah, you're testing me now. I think it was it was about 3 months from memory.
Yeah.
And it was like most things, it was a very slow start. There was a lot of conversations, and then it came around to the point of actual commitment. And from when we decided that we'd sent that drawing that Rick talked about, the render, from when we sent that to actually the client going, yeah, let's go ahead, let's do this, to us going on site, I'd say would be in about 4 to 6 weeks. Like, it was actually quite a quick development, quick turnaround. Some of the more complex scopes we do up to 18 months. Some of the smaller stuff we do with turned around in less than a week. Like at the moment, we're working on a custom centralizer. Came in Monday, will go out Friday, sort of thing. So we can sort of support a lot of different scopes. But yeah, I'd say from start to finish on this one was about 3 or 4 months.
Just want to continue with that one, Jared. So, okay, 3 to 4 months to get to site. Now we are on site. What sort of times are we talking about? So you've rocked up on site, you've done your inductions. Yeah, how much time did it take to do your setup? How much time did it do the inspection itself? And then sort of demob and de-rig all the kit? Yeah,
good question. So all up 4 days. Every time you go to site, the first day is a write-off. You're doing inductions, you're getting the lay of the land. So that was day 1. Day 2 was the Angular's. So we set up. It was quite hard. Like, we had to lug everything up to the top, set up. So that was a full 12-hour day. Not too much on the way of breaks those days. And that covered the Angular's. And then this third day was the the patterns across the centre. So that was most of those. That was a lighter day, I guess, a lot faster, probably because we'd done it in the morning, the day before. So we kind of had a good idea of how to set up and what we needed. And then the fourth day was just cleaning the gear on site before it got shipped back. So there was a lot of that and just preparing it for shipping and sort of handing the data and the reporting off. So all like on site, like 4 days really. Yeah. But really 2 days of actual inspection.